Hello everyone, my name is Siso, but you can also call me Coach Smoo. Welcome into the Mathsbuddies tutorials. In these tutorials, I get to share with you methods that can help you improve your math skills. So if you are returning, I'd like to thank you for coming back, and if you are new, I'd like to welcome you, and please remind you to subscribe so that you won't miss when another video gets uploaded. If you also like watching this video on Facebook, please make sure you like it and also share it with other people so they can also be able to benefit from this valuable information. So without wasting any further time, we're going to jump straight into today's tutorials. In today's tutorial, we're going to be going through a summary of Euclidean geometry. So what I'm going to be doing is I'm going to be giving you a theorem, all right? And then after giving you a theorem, I'm going to be giving you the reason that you can actually write, and also what does that theorem mean in terms of angles, right? So let's go ahead and dive right into it. Now the first thing that we're going to be going through is you understanding key things on Euclidean geometry, right? So here we're going to be discussing all things about Euclidean geometry. Now in Euclidean geometry, the theorems that you study there, you need to understand the main purpose of them, right? So the main purpose of them is for you to study the angles, right? So that is the first thing that you must know when you're dealing with the Euclidean geometry, that there we are dealing with angles, or we are finding angles. But then of course, the way it is structured, they made it so in such that it becomes more complicated with you, in a sense that it becomes difficult for you to find the angles, right? So that is why now we're doing this video, to help you understand that what does it mean when it's given like that, and then what does it actually mean in terms of angles, right? So let's go ahead and then start with this circle here. So the first thing that we're going to be talking about, it is going to be helping you to analyze the lines that you're going to be given into Euclidean geometry. So let's say, for example, here we have our center. So I'm going to put in the center here. So let's say we have a circle, and then this is a center. Now here what I'm going to be doing is I'm going to be explaining each line that is given in this circle, or that you might encounter in the circle. So the first line, I'm just going to be drawing a line from the center and then go straight into the circle like that. And then this line in Euclidean geometry, we call it a radius, right? So a line, any line that's starting from the center, right, and then touches the circle and doesn't pass that circle, we call it a radius, right? Then now secondly, we also have a line that will be from one end of a circle to another end of the circle like that, and then we call this line a chord, right? So any line that is touching a circle twice and doesn't pass a circle, we call it a chord. Then now let's move on into another line. So another line that you're going to be dealing with is a line that is touching the circle once, right? So I'm going to draw the line like that. It's outside, touching the circle like that. So this line is called a tangent, right? So another line that you're going to be dealing with, let me write this tangent. And another line that we're going to be talking about when you're going through the theorems, it is a line, or it is a chord that is basically passing through the center, right, of the circle. Now we call this chord a diameter. All right, so now here we have what? Radius, chord, tangent, diameter, right? Now those are the main lines that you're going to be dealing with when it comes to Euclidean geometry, and also to the theorems that you're going to be getting, right? But then now there's more lines that you still need to do, which is sometimes you're going to be getting lines that are passing through the circle like that. So these lines, or this line, we call it a secant. So I'm going to write it there as a secant, right? And then any line, right, any line that is drawn anywhere, right? For example, here you see I'm just drawing a line, but then now I drew this line from the center, right? And then it didn't get anywhere, right? So we basically call this a line because it has no meaning, right? So the ones that you see here, radius, diameter, chord, tangent, and secant, right? Out of those ones, the ones that I would say that you always need to make sure that you keep them in mind, it is these ones. It is the radius, the chord, the tangent, and the diameter, right? So because those are the four lines that you have to know. All right, so now that we have the lines that we're going to be talking about in the Euclidean geometry, now let's go ahead and jump right into the theorems, right? So before we get into the theorems, we're going to first need to talk about the two types of angles that you're going to be working on, right? So here we're going to be talking about the types of angles, right? And then here we're going to be talking about the types of triangles that you're going to encounter, right? So let's go ahead and start with the types of angles. Now, there are two types of angles that you're going to be dealing with, or that you deal with in Euclidean geometry. So we have the first angle that is formed by two radius. So I'm going to call this R1 for radius 1 and R2 for radius 2. So which angle is that? So this is this angle, right? So when we look at this angle, we call it an angle at center, right? So this is an angle that is formed at the center. Now this angle has this space that it takes, right, from the circle. Now that space that it takes from the circle is called a minor arc, right? So now we have another type of an angle that you're gonna come across with. So another type, it will be an angle formed by two chords. So I'm just gonna draw like that. Let me just, right? So here I'm gonna say chord 1, and then this is of course chord 2. And now chord 2, right? So the angle that this chord forms is basically this angle here, right? And then we call this angle, it's an angle at the circumference, right? Now this angle also has this same space, right? Now this same space is called a minor arc also, right? And then now those are the two types of angles that you're going to be dealing with in Euclidean geometry, or that you have already dealt with. And then now let's go on into the types of the triangles that you're going to be also encountering in Euclidean geometry. Now the types of angles that you're going to be encountering in Euclidean geometry, the first one is called an isosceles triangle, right? So now here I'm going to be drawing a type of an isosceles triangle that you tend to get, right? So a type of an isosceles triangle that you always get most of the time, or that you should always look for, is when you're given two radius like that, right? If you're given two radii, so I'm going to say R1 and R2, right? So in this type of an isosceles triangle, you're going to be given a chord that is joining these two radii, right? Now, because of this, right, you'll notice that the radii are equal to one another, which is R1 is the same as R2, and because of that, it means now these angles that they carry here are also going to be equal to one another, right? So we call this base angles of an isosceles triangle. So I'm going to write here the reason for this. Reason for that, it is the base angles of an isosceles triangle, right? So this is where R1 is equals to R2. So it's formed because of R1 is equals to R2, right? And then we have another type of triangles, right? So this type of triangles that you're going to be encountering is when you're given two triangles. So I'm going to draw them separately like that. So these two triangles that you're given here, okay, let me just make it this line that is straight like that, and join this one there, right? So in these angles, let's say we have this side there, so I'm just going to draw another triangle from the other side of the triangle of the circle. So let's say these triangles here, this side is the same as that side, right? Now these triangles, if you're having a triangle in a circle, or if you have two triangles in a circle that firstly all three corners are touching the circle, as you can see, 1, 2, and 3. So same here, 1, 2, 3, right? So both of these triangles, they have their corners touching the circle, right? So when you have that, right, what does this mean? So this means now the angles that are opposite these sides are going to be equal to one another. Then the reason for that will be if you have equal sides, right, then you should have also equal angles, right? Okay, so here those are the types of angles, types of the triangles. So now let's go ahead and talk about the theorems that you're gonna be dealing with, right? Or that you need, that you will deal with, and that you need to actually take into account, right? Or that you need to memorize, right? So the first one here, you see that we have three groups here, or I have three circles and three circles. Now the reason for that is because I have grouped them according to their keywords, right? So the first keyword of the first type, so I'm going to call it the group 1. So we call this one centers, right? So why do we call them centers? It's because in all three of them, right, their theorems, they have to do with a center. They have something that has to do with what? With a center. All right, so let's start with the first one. So the first one, it says if there is a line, remember a line, we said most of the time line is drawn from the center. So if you have a line drawn from a center, right, but then this line is perpendicular to a chord, so I'm going to draw a chord like that, right? This line is drawn from a center perpendicular to a chord, so which means this is 90, right? Then what this line does is that it divides the chord into two equal sides, right? And the main reason, or the key word or the words that they use for that is that it bisects the chord, right? So to bisect, it means it is to divide a line into two equal halves, right? So now here we're saying this theorem, a line drawn from a center perpendicular to a chord bisects the chord. So it means the reason for this, right, is that we're saying line from center, right, perpendicular to chord, right? So that is the reason for that theorem, right? Now, if we're having this theorem, what does this theorem mean then? So now this basically means that if here I have A, B, and then C like that, so this basically means now here angle OCA, right, is the same as angle OCB, and they are equals to 90. Now remember what I said earlier, that the main focus of the theorems is for you to understand what it means about the angles. So this is basically what this one means about this angle. So let's go ahead and look into the second one. Now the second theorem says that if you have an angle that is drawn from the center, if you remember the angle at center, we said it was an angle that is formed by two radii, right? So an angle formed at the center, right, that subtends an arc or a minor arc is twice an angle that is drawn at the circumference. So I'm going to use a different color for the one that is drawn in the circumference, like that. So this one is a line that is at the so it is an angle that is at the circumference, but notice that it also has what? The same minor arc, right? So what are we saying here? We're saying that the angle formed at the center, it is twice the angle at the circumference. So that's what we're going to write here. So what's the reason for this? So the reason, it is angle at center, it is 2 times angle at circumference. All right, so now what does this mean now when it comes to actual angles, right? So if here we have OA, B, C, right? So basically what this means is that angle AOC, which is the angle at the center, it is 2 times angle at the circumference, which is angle B. All right, So now let's move on into the next one. Now the next one says here an angle formed, right? Or it says if you have a diameter, so I'm going to draw my diameter there. You see there, remember a diameter is a chord that passes through the center of a circle. And then now it says here we have a diameter and the angle like that subtended or formed by that diameter, and then that angle is basically going to be 90. So what does this mean? So it means an angle subtended by a diameter is equals to 90. So what is going to be the reason for this? So the reason for this will be angles, right? Angle on a semicircle. On a semicircle. All right. So now according to the actual angles, what does this mean? So it means if I have angle ABC, right, then angle B is going to be equals to 90. All right, so that is the first group, which is the one that is called centers. So now we're going to move on into the second group. Then the second group, we call it cyclic quads, right? So the reason why we call it cyclic quads is because in all of these three next theorems that we're going to be talking about, they're going to involve cyclic quads. All right, so let's go ahead and start with the first one. So the first one says that if you have a circle and then there's a quad inside that circle, so a quad will be a shape that has four sides, but then all those four sides are formed by chords. So you see here I have four chords. Right? So what does this mean? So it means two opposite interior angles here are going to add up to 180, right? So the reason for this is that two opposite, right, angles of cyclic quad, right, add up to 180. All right. Okay. So now let's go ahead and look into angles so that we can have a conclusion about this. So let's say we have A, B, C, D. So what does this mean about the angles? So here, two opposite angles will be A plus C. So when you add those angles, they add up to 180, right? Or if you add B and D, you get 180. So that's what the theorem says, right? So now let's look at the second one. So the second one says that if you have again a quad or a cyclic quad, but then this cyclic quad, the fourth side or the fourth chord, extends like that, right? So what this means is that an angle that is formed externally, right, or the exterior angle of the cyclic quad is equals to an opposite interior, right? So the exterior angle, so firstly let's start with this first one. Remember we said opposite angles supplemented. Then this one, it says the exterior angle needs to be equal to an opposite interior. Now the reason for this one, when you write the reason, we just say the exterior angle of the cyclic quad. All right, so what does this mean? So again, in terms of angles, so we're going to put in angles A. Let me just do it this way. A, B, C, D, E. So this means now here, angle ADE, which is an exterior, is equals to angle B. Right? Okay. Then now we go to the last one of the cyclic quads. So the last one of the cyclic quads says if we have a chord like that, so this is also a cyclic quad, but then now still it has four sides, but it's not the one that we had initially. So now here it says that angles that are formed by this quad are going to be equal at the top, and those ones at the bottom are also equal. So what does this mean? This angle is the same as this angle, and that angle is the same as that angle, right? So we call this angles subtended by the same arc, right, are equal. So which arc am I talking about? Remember, we said if you're talking about this angle and that angle, those are the angles that are at the circle or circumference. Now, if I'm asking you which arc did they form, so this arc is the one that formed them. Now notice that they have the same arc. So because they have the same arc, it basically means now that they have the same angles, right? So the reason for this now, it means now these are angles on the same segment, or you can just say same arc, right? Now, of course, we have to translate this into angles. So A, B, C, D. So what does this mean? So basically what this means is that here angle A is the same as angle B, right? And angle C is the same as angle D. All right, so now we're going to move on into another group, and then the last group here, which is the group 3, we call it tangent. Now the reason why we call it tangent, it is because we're going to be using a tangent as our reference here, or the key thing here, it is a tangent. All right, so let's go ahead and start with the first one. So here I'm going to say if I have a tangent, so I'm going to draw a tangent like that. Just need to make sure that I draw a line that is touching the circle once. There we go. Okay, so a tangent like that. So this first theorem says that if I have a circle center and then I have a radius, right? Then the radius is basically touching where the tangent has touched the circle. That radius is going to be perpendicular to the tangent, right? So now here, what are we saying? The reason for this, we're saying the radius perpendicular to the tangent. Okay, what does this thing actually mean in terms of angles? So we're going to go back into the angles. So let's say this is TAN for tangent. So basically what this means is that angle OAT is the same as angle OAN, right? And they are equals to 90, right? Okay, so let's move on to the second one. So the second one says that, again, we need to have a tangent, right? So if I have a tangent like that, right? And then in this tangent is a triangle inside. So this triangle, of course, it's going to have 3 sides like that. All right, so what does this theorem say? So this theorem says that an angle formed by a tangent and one side of the triangle, angle formed by a tangent and one side of the triangle, right, is going to be equal to, so let me just put this angle like that as a dot, and then this angle is going to be equal to an angle opposite this side of the triangle. And if you check here, this is the angle that is opposite that side. And then the other way around is also true. An angle formed by the tangent and one side of a triangle, it is equal to an angle opposite this side, right, in the triangle. So what's the reason for this? So the reason for this one, we call it a 10-chord theorem. We call it a 10-chord theorem. Now, what does this mean in terms of angles? Okay, so we're going to say we have TAN. Of course, then it's going to be ABC. ABC. So what this means is that angle CAT, right, is the same as angle B, and angle BAN is the same as angle C. All right, so now let's do our last theorem, right? So the last theorem says that if we have two tangents like that, so I'm just going to draw two tangents, and then I'm going to just bring them closer up until they meet each other. All right. So this theorem says that two tangents from the same point are basically equal in length. All right. So what does this mean? So this means here, if I have two tangents, and then they both started from the circle, of course, and then from there they then came into intersection like that. Now what this means is that these tangents are going to be equal in length. So which length? So the length from where they touch the circle to where they intersected each other, they're going to be equal, right? Now the reason for this one, of course, is going to be tangents from the same point. From same point. All right. Now, what does this actually mean? Now, this one, it actually means now that if these tangents, first of all, they're going to be equal in what? In length. But then now, when they're like this, they won't have any meaning. So it will just end there. But then now, if it happens that there's a line, right, that is joining these two tangents, right, then this line will then form a triangle that is called an isosceles triangle, right? So now because of that, it means now if we have this tangent as AB, right, first tangent AB and the second one as CB, then here we can then say here that number one, we can say that AB, right, or we can just say, because remember we need to talk about the angles here, so you're going to say angle BAC, right, is the same as angle ACB, right? And then the reason for that then will then be the base angles of what? Of an isosceles triangle where AB is equals to BC, right? And the reason for AB being equals to BC is basically the tangents from the same point, right? Now, these are the theorems that you're going to be talking about, right? But in Euclidean geometry, this is not where Euclidean geometry ends, right? This is what you've learned in when you were doing grade 11, right? But then now there's also some of the theorems that you've learned into grade 10, and those are the ones that are involving parallel lines. So now what we're going to do is we're going to quickly talk about the parallel lines so that you can also understand what is happening with those ones, right? So let's go ahead and write parallel lines, right? So with parallel lines, what is happening? So with parallel lines, you have corresponding angles, right? So I'll put it as F, and then you have co-interior angles, draw it as U, and then you're going to have alternate angles, so I'm going to write it as N. Now, what is happening with corresponding angles? Corresponding angles are equal to one another, right? So what does this mean? So this means that here, if I have two lines that are parallel to one another like that, right? So the angles that are inside here in this F shape are going to be equal to one another. So the reason for this is corresponding angles. We know corresponding angles are what? Are equal, right? So now what does this mean? So this means again, if I can say I have A, B, C, D, and E, then with this, you can conclude that angle BAC is the same as angle DCE, right? Okay, so now let's go into the next one. The next one, it is co-interior angles. Now, co-interior angles, what do they do? They add up to 180. So co-interior will be the angles that are inside that U shape. So which means now here, the reason for this will be co-interior angles. What do they do? Add up to 180. So you need to remember that part, because Most of the time, people they tend to make mistakes. Think that they call interior because of the corresponding were equal, and then now everything that has to do with parallel lines has to be equal. No, it doesn't work like that, right? So it's only the one with U shape that adds up to 180, but the other two, yes, they are equal. All right. So now here, A, B, C, D, it means now angle B plus angle C is equals to 180. All right. And then our final one will be the N shape or the Z shape, right? Now here, these are alternating angles. So alternating angles are equal to one another. All right. So what's the reason here? The reason we say that alternating angles are equal, right? So if they are equal, let me just write it as alternating angles equal. So this then means now if I have A, B, C, D, right, and then here I will say angle B is equals to angle C, and that is basically how we end our video on how to basically approach Euclidean geometry. Now, this is the quickest way that you can learn to understand all the theorems that you're going to need when you're dealing with Euclidean geometry. Now, this is for both grade 11 and grade 12. So please be sure that you take as much notes as you can, watch the video twice, and then if there's anything that you would like for me to actually do for you, make sure that you can also leave that in the comment. And also, that's it for this video. Please don't forget to actually making sure that you subscribe, and also leave a comment and share this to your other friend. And until next time, stay blessed for the best. Cheers.